Today I will be explaining problem 1C. As you can see, we're given the graph, and the prompt is that we must draw the position versus time graph, the velocity versus time graph, and the acceleration versus time graph for the situation from this graph. And we are supposed to assume that the maximum and minimum values are 1 and -1. And we must estimate the velocity and acceleration curves from this graph, which is the position graph, and then describe a plausible story for what this graph is. So this is already the position graph. This is from y to y to time. This shows the position as an object moves in the y direction from 0 to 4 seconds. And so from there we can get the velocity graph. So as you can see, I redrew the position graph, and so we know that the slope of position is velocity. If you take the derivative of position, you get velocity. And so therefore, if we look at the position graph, we can see that from 0 to 1, the graph is increasing, the slope is positive, and therefore the velocity is positive. So if you look at the velocity graph, you can see that from 0 to 1, the graph is positive. It's above the x-axis, because in the position graph, from 0 to 1, the slope was increasing, and when you have a slope that's increasing, that means the slope is positive, and therefore, since the slope of position is velocity and the slope is positive, the velocity graph is also positive over there. And then you can see from 1 to 2, we have a decreasing slope, or from 1 to 1.5, a decreasing slope, a negative slope. Therefore, that means the velocity is negative. So from 1 to 2, I'm sorry, this may be 2. So from 1 to 2, the velocity is negative. It is underneath the x-axis. Then from 2 to 3, we can see that the graph is increasing, therefore a positive slope means a positive velocity. So from 2 to 3, the velocity is positive, and likewise, you'll complete the graph like that. Then, to draw the acceleration graph, we know that the slope of velocity is acceleration. So the derivative of velocity is acceleration. And so we can see that from 0 to 1.5, the slope is negative. And since the slope is negative, that means the acceleration is also negative. And so if we look at the acceleration graph from 0 to 1.5, we can see that it is underneath the x-axis, meaning that it is negative. And then from 1.5 to 2.5, we can see that the velocity graph is increasing, therefore the slope is positive and acceleration is positive. So from 1.5 to 2.5, we can see that the acceleration graph is above the x-axis, meaning acceleration is positive. From 3 to 4, from 2.5 to 3.5 in the velocity graph, we can see that the slope is negative, therefore acceleration will be negative because the slope is decreasing. And as you can see, it's likewise on the acceleration graph. And so, what's a plausible story for the situation? The situation could be someone on a swing going back and forth, and as you see, if when they're going back and forth, their displacement at the end would come back to where they started, at the starting point, and they're just going back and forth, which you can see in the y-axis or in the y position graph. And so therefore the velocity would be increasing and decreasing and increasing and decreasing as they swing forward. They get to a velocity of 0, then they swing backwards with a negative velocity. And to swing forward, you would have a positive acceleration. You would have to increase your velocity, and when you're increasing velocity, there's acceleration. When you get to 0, there is no acceleration, and then you would have to swing back down, and that's when you have negative acceleration, negative velocity. And so that is the situation for this graph, and that is the explanation for this problem.